Gracious Kanzieni from Educare, Tanzania. Warmly welcome in our media so as you can have our online tutorial. My student, we have our chemistry subject and our class level is Form 5. So today we are proceeding with our physical chemistry and we are discussing our main topic, which is concept of gases. We are discussing the concept of gases. So for today, we are going to proceed with the concept of Avogadro's law. You can remember, or I can remind you that in the previous session we tried to talk about the gases law. Tukaona kuhusiana na Avogadro's law. So I hope up to now you are aware about Avogadro's law. So today we are going to discuss on how the Avogadro's law can be represented in a graph way. So the graphical representation of the Avogadro's law is shown in the figure 1.9. We are going to see it and I'm going to illustrate it for you as we discussed it in the previous session. So this is our graph now, which represent or which can illustrate the whole concept of Avogadro's law. So my students, I hope this is clear for you. Yes. As you see here, first of all, our graph is straight line. It obeys the straight line equation. Mean that our graph, as you increase the number of mole, also the volume increase. As the volume increase, also the number of mole increase. Kwa sababu tuliona kwamba Avogadro's law at the same temperature and pressure, there is an equal volume of all mole particle or of number of particle, ambapo tunaongelea the number of mole. Tukaona kwamba the volume is directly proportional to the what? Number of mole or number of particle. So if there is an increasing of the number of mole, at the same time the volume will increase. Mean that our graph we are going to have the y-intercept which is equal to 0, kwa sababu graph yetu itapita here, itapita hapa, tutapata zile negative sign. Tutapata zile negative sign, kwa hiyo graph yetu itakuwa imepita hapa na tutapata straight like this straight line like this. Our y-intercept itakuwa sasa na 0 kwa sababu huku hatuna zile negative value. So you can see that here the volume is direct proportional. Kama unavyoona hapa, tumeindicate hapa this one number of mole which is equal to 1 and V1, but also you see N2 V2, mean that from here to here there is an increasing in number of mole of the particle, but also from here to here there is an increasing of the number of the the volume. Volume ukitoka hapa mpaka hapa, maana kwamba kuna kiwango kimeongezeka. Ukiconsider from 0 up to here and from 0 up to here, kuna increasement imetokea hapa. But also the same in this side. From here to here the number of mole, and from here to here there is an increasing. So there is a direct proportion between the volume and the number of mole or number of particles. So that is all about the Avogadro's constant. So I hope now you are aware and it is clear concerning the illustration of Avogadro's law. So you see the change of volume with the number of mole, the way the graph can be represented. Very simple. Sometimes we can be given a data, specific data, and solve the different problem concerning the given data of the graph and so forth. Okay, so now we can see now how to apply the Avogadro's law equation. Avogadro's law equation. In the previous session we tried to drive it. Tukaona kwamba the way volume is directly proportional to the number of mole, the same we are going to have the V is equal to V1 over N1 is equal to V2 over N2 because of that proportionality constant. So kwa kuwa tulishaona equation yetu, so how can we solve the different problem concerning that equation? So here we can have our question here simple and clear. Let us see how we can apply the Avogadro's law equation. Example, a container that is not full of air has a volume of 275 milliliter and containing 0.012 mole of air. What will be the volume of the container after a piece of a dry ice ambayo ni solid carbon dioxide weighing 1.0 gram. This is amount, this is mass of this carbon dioxide gas is added and allowed to sublime. Kwamba hii ni kama scenario hii ni kama scenario kwamba container ilikuwa haipo full with what? With air. Ilikuwa haipo full with air. Anasema volume of this one containing this one of mole air. So within the container tulikuwa na this volume of air, but also tulikuwa na number of mole of air ambayo ni 0.012. But what will be the volume of the container? Sasa tunataka kujua unknown volume of the container endapo baada ya piece of a dry ice solid carbon dioxide ikawa added pale. Kwa hiyo pale tumefanya addition ya nani? Ya carbon dioxide. Sasa tulivyofanya hii addition ya carbon dioxide, volume itakuwa ni ngapi? Kwa sababu tumeambiwa ile container is not full of air. Container ilikuwa haipo full of air. Kwa hiyo unaona kwamba kuna addition ya hii. Sasa baada ya kufanywa addition ya hii, what is the volume now? Kwa hiyo hapa tunaona relationship iliyopo kati ya nini? We need to know the relationship between volume and the number of mole. Sasa kama mwanzoni tulikuwa na this volume, ina maana baada ya addition of this carbon dioxide we expect increasing of the volume. We expect increasing of the volume. But before, we have to understand, how about the number of mole of this carbon dioxide plus the number of mole of the air? Kwamba number of mole of air tayari tulishapewa, lakini kuna addition ya carbon dioxide. Kwa hiyo tunatakiwa tujue the total number of mole ili finally tuwe na conclusion ya number of mole. Tujue initial number of mole and the final number of mole. Ndo pale N1 and N2. Okay, let us see our solution. Let us see our solution. So this is our solution, very simple. So my students, as you see, we have the volume, which is 275 milliliter, but the volume 2 is unknown. Ndo tunatakiwa tuitafute. And the number of mole of air tulishapewa ni ngapi? 0.012. Hii ni number of mole of air. You have to understand. Lakini ukiangalia kwenye swali lako pale umeambiwa kwamba addition of carbon dioxide ilikuwa na uzito wa ngapi? Ilikuwa na uzito 1 gram. Ina maana ile ilikuwa ni mass. So we have to find the number of mole of this carbon dioxide. Sasa from the previous, wakati tunafanya derivation of this concept of mole, tuliona kwamba the number of mole is equal to mass over molar mass of a gas. So mass of the gas tumepewa ni 1 gram. Lakini molar mass of the gas ni sasa na ngapi? Sasa molar mass hii ulishasoma kuanzia upo form 2. Tuliona kwamba ni ile summation ya zile masses za given compound zako zote. Kwa mfano carbon ina mass ya ngapi? Ina molar mass ya ngapi? Oxygen ina molar mass ya ngapi? Kwa hiyo utakuja kuona kwamba kwenye carbon ni 12, lakini kwenye oxygen ni 16, lakini it is a gas here. So 16 mara 2, lakini pia utajumlisha na carbon ambayo ni 12. Obviously the total will be 44 gram per mole. So the summation of molar mass of the element which make the compound of carbon dioxide gas. So you can see that here we can get the number of mole of the carbon dioxide. So we take 1 gram divided by 44 gram per mole. Why gram per mole? Kwa sababu hapa tunaangalia summation of the molar masses. Summation of the molar masses. Sasa SI of molar mass mean that we have gram per mole. Gram per mole. So obvious gram and gram will cancel to each other. We are going to remain with the mole, ambapo tunaenda kupata this mole. So after there we can see that the number of mole ambayo ni N2 itakuwa sasa na ngapi? Kumbuka tayari N1 tulikuwa nayo ambayo ni ile number of mole of air. Sasa tunakuja kuangalia the number of mole ambayo inatakiwa ni baada ya addition ya ile carbon dioxide, right? So number of mole ambayo itakuwa ni N2 itakuwa ni jumla ya zile number of mole za zile particle ya air ambayo ilikuwa ina exist, lakini pia na ile ya carbon dioxide ambayo imekuwa added pale kwenye ile container ambayo ilikuwa haipo full with air. So tutachukua mole of air plus mole of carbon dioxide. Kumbuka mole of carbon dioxide tushaipata. So very simple, tunachukua ile given number of mole ya air, tuna plus na ile number of mole of carbon dioxide ambayo tumecalculate. Finally tunaenda kupata that one. We are going to get this value ambayo ni 0.03473 number of mole. Kwa hiyo hapo itakuwa ni number of mole ambayo ni ya pili, ile after. So now we have the N1 and N2, and you can refer back, we have the volume 1, we are required to find the unknown volume 2 ambayo ni baada ya ongezeko la carbon dioxide. Very simple, we refer to our Avogadro's law equation ambayo inasema V1 over N1 is equal to V2 over N2. We are looking, or we are finding the volume 2. So the volume 2 will be equal to V1 times N2 over N1. So we substitute our value, and finally we are going to get this one as a volume. So therefore the volume of the container will be equal to this one. So that is how you can solve the different problem involving this concept of Avogadro's law equation. There is a lot of problem here. Mimi nimejaribu tu kukuwekea mfano na kukuonyesha ni namna gani ambavyo unaweza ukaapply hii concept, lakini unaweza ukachukua muda wako ukaenda kwenye past papers, kwenye vitabu, you will see a lot of question. Use them so as you can enhance your understanding. So my student, after there, I would like to say this marks the end of our discussion. Thank you so much for watching our Media Educare. Bye bye.